In this video, I will go through the one analogy that helped me understand the whole of A-level electricity. We start with a simple circuit, and instead of a battery, we have a house, and instead of resistors, we have two hills which require energy to walk over. Two people move around the circuit. Each person has 10 joules of energy. As they move around the circuit, they reach a junction. At the junction, they both take different paths. One person might go this way, and the other person might go this way. This shows us that current splits at a junction. However, they haven't had to move over any obstacles, so they haven't had to use up any energy. They both still have 10 joules of energy. This shows us that potential difference is the same across components in parallel. So in other words, potential difference in this loop is the same as the potential difference in this loop because they both still have 10 joules of energy. But each person must use some energy to get over the obstacles. For example, the first hill might take 7 joules of energy to walk over, so this person will be left with 3 joules. This hill might take 3 joules to walk over, so they'll be left with 0 joules. The same for the hills below. This hill might take 5 joules to walk over, so the person has 5 joules of energy. This hill might take 5 joules to walk over as well, so the person's left with no joules of energy. This shows us that potential difference is shared proportionally in series, and that means that it's shared depending on how large the resistance is, i.e. how much energy is required to walk over that hill. But these people, they then meet at the next junction. So this person walks from here, and this person walks from here. So the number of people in my circuit hasn't changed. That means that charge is conserved. However, they both now have no energy. So the difference in energy from the start to the finish is going to be 10 joules at the start minus 0 joules at the end. Often in electricity, we don't talk in joules, we talk in volts. And if you recall from video 1, potential is energy per unit charge. And for an electron, Q, so charge is the charge on the electron, which is 1.6 times 10 to the minus 19 coulombs. So we can substitute our energy into the formula. So we had a change in energy of 10 joules per an electron, which has a charge of 1.6 times 10 to the minus 19 coulombs. If we work that out, we get 6.25 times 10 to the 19 joules per coulomb, which is the same as 6.25 times 10 to the 19 volts, because 1 volt is 1 joule per coulomb. In my next video, I will be applying this analogy to the series circuit rules.